In this series of video lectures, we're going to look at three of the fundamental aspects of programming. Those are input, process, and output. Let's get started with talking about input. Whenever we write a program, we're most likely going to want to take some data in some fashion so that we can process or modify it. So input is the first place that we want to start. Most of the time this semester, we're going to get input for our programs from the keyboard. It's going to be our standard input device. At this point in time in modern computing, the keyboard is where most information comes from for processing in programs. It's also not uncommon, though, to get information from a file. We could also get information downloaded from the internet, or say the camera on your device, or a video. We could also use voice processing. So maybe our program is getting input from the user's voice. Maybe we're working with something like a thumbprint scanner and we're getting some type of data about a user's thumbprint into our program that we need to process to maybe unlock the phone. Whatever it is, input is going to be external information that we are retrieving into our program so that we can take some type of action based upon that information. And for most of what we do this semester, that is going to be the keyboard. Now, once we get some input into our program, we're going to need to store that information in our program. One of the concepts we'll talk about a lot this semester is the concept of a variable. And a variable, the formal definition, is a named location in memory. But in reality, what we're talking about is a box or an envelope or something that we can use to hold on to a value that we want to use later. So the idea here is that we have a value, something that the user has entered into our system or something that we've put into our program ourselves, and we want to hold on to it so that later on we can reference it. And the idea is that we can set up these storage locations, put a piece of data in it, and then later on we can access the data that's in there or modify it or update it. And one of the things that's really important to understand about variables is that a variable can only contain one value at a time. So if I put a number into a variable to hold on to it till later, and then I go ahead and I put another number in that variable, the item that was previously in the variable will get deleted. If we think of this like a magic box, let's imagine I have a shoebox, and in that shoebox is a shoe. And then I go ahead and I try to put another shoe inside of that shoebox. What happened to the first shoe? Well, it would get deleted. It would just disappear. It would be overwritten by the new shoe. This is a little bit of an odd concept at first, but one of the cool things is that we can take advantage of this behavior, that new items going into a variable overwrite the old value. And we'll look at some ways by which this happens when we get to a programming example. Next up, we're going to be creating these variables, and we're going to have to give them names. So whenever we want to hold on to something, the storage location in which we put data is going to have to be given a name. That name should be sensible. So for example, if you're like me, probably somewhere in your house, you have a box that's labeled pictures. And my guess is, if you're like me, you've got things in there that aren't pictures. I've got picture boxes that have electronics in them, in addition to pictures, and a whole bunch of other mess of stuff. And it's not a really useful label at that point because the label doesn't accurately describe the contents. It'd be like having a shoebox, and on the outside, instead of the label shoes, maybe I had the label tax information, but really I opened it up and there were shoes in there. Again, the names that we give our variables, the labels that we put on our storage locations should be relevant and related to the information that they're going to contain. So if we're going to have a variable named to hold the value 3.159, 3.14159 pi, then what we would have to do is make sure that we named that pi. That would be a good name for that variable. The letter P might not be appropriate. So, a couple things we need to know about building and naming variables. For now, we do not want the variables that we utilize to have spaces in their names. You should try to get out of the habit of using spaces in any names that you use in computer programming, whether it be the name of a file or it be the name of a variable. Try to get out of the habit of using spaces when naming things. It's a bad habit and it can cause problems. Next up, we also want to standardize on the letters and characters that we're using to name our variables. So we want to try to limit ourselves through lowercase a through z, uppercase a through z, possibly the underbar, which is when you hold down shift and hit the dash key on your keyboard, and the numbers 1 through 9. Those standard alphanumeric characters are what we want to try and utilize for naming our variables. Please note that you cannot and should not name variables with a number as the first character. So it's fine to have a variable named number 9 because it starts with the letter N, but you wouldn't want a variable that starts with the number 9, like 9 number would be incorrect. So just remember the variable names should not have spaces, they should use standard alphanumeric characters, and they cannot start with a number. Additionally, you're going to see me utilize a naming convention called intercaps, where we capitalize certain letters within the variable names that we use if the names that we're using are multiple words. So intercaps is this process of making things more readable by using caps, capital letters, inside of variable names. So you'll see that here in a second. Here are some examples of good variable names. Notice that my first variable is called myvar. I capitalized the V in var so that it makes it a little more readable. And I guess that would be shorthand for my variable. Next item down is the capital, under that first example is pi. So pi would be an appropriate name. Notice the next variable down is plan9. Notice it ends with a number, so that's fine. I just cannot start with a number. If you feel like you want to use spaces in variable names, you may be wondering, well, why did I recommend the underbar? Well, notice some underbar important underbar value makes that a little bit more readable, makes it feel like there's spaces in the name, but there actually are no spaces in the name. And then finally, if you don't like the underbar and you prefer intercaps, which is the way I tend to name variables, notice that I've gotten rid of the underbar in the final example and replaced the letter I and the letter V with capitals and used intercaps to basically make that variable more readable. So these are just some examples of good variable names and some ways that you can build variables that are going to be more readable within your program. It is more important that you are consistent than correct when it comes to dealing with variable names. What I don't want to see is that you use underbars in one case and intercaps in another, or in some cases you use all lowercase letters, and in other cases you use all uppercase letters. I'd prefer that you find a style that you find readable and stick with it. So one of the things that we're going to work on is consistency. If you are consistently wrong, let's say you don't know what to do, make a decision about how you think you should do something and make sure that you execute every item within your program using that specific approach. That way, if you're wrong, I can give you one piece of feedback and then it's easy to fix across your program. If you are inconsistently wrong, that becomes more of a problem because then you can't necessarily do a find and replace, or you would require different types of feedback in different areas. So one of the most important aspects of this class at this point, and you'll hear me say this probably over and over again, is consistency is greater than correctness. If you are consistently incorrect, that is much more fixable than if you are inconsistently incorrect. So try to make a decision about how you think you should proceed and stick with it. So let's go ahead and see how some of these items play out using our programming environment, Visual Logic. Visual Logic can be downloaded from the Visual Logic website at visuallogic.org. You'll want to go ahead and download the software to your computer. It runs only on Windows, so if you are intending to run the software on a Macintosh, you'll need to set up a virtual environment. And I can post additional instructions for how to do that if you have any questions. In my specific case, I'm going to go ahead and launch Visual Logic by double-clicking on it. I already have it downloaded and installed. Visual Logic is not free software. It's software that can be utilized in a demonstration mode for free, but if you want to be able to save and work on files at a later date, you're going to need to get a license. If you are taking this course for credit, that means that the key to utilize Visual Logic was purchased along with your textbook for this course, and you'll be able to utilize that code by following the instructions to generate a pin that you can use when using Visual Logic. Every time you launch Visual Logic, you'll be presented with this launch screen, and you'll be able to click continue, and at this point, every time it will ask you for your pin file or key file so that you can go ahead and set this up. They use the term VLSIG file, but really it's just a way to identify you. And every time you run the program, you'll want to browse to your VLSIG file and select it. So I've got mine stored on this computer. I'm going to click this, and when I hit open, we will go ahead, it will prompt you to say, hey, is this VLSIG file yours? And if it is, it will go ahead and launch Visual Logic, and we'll be ready to get going. VisualLogic is a great program to learn programming, and it's a really nice environment that we found to be very successful with teaching students new programming skills. Once you have launched VisualLogic, you'll be presented with this basic interface. VisualLogic allows us to draw flowcharts, and those flowcharts can be executed just like regular programs. And in this specific case, we know that every program is going to have a beginning and every program is going to have an end. And this is the way all programs work. At some point, somebody has to launch a program, and at some point, the program's either going to be terminated by the user, it's going to crash, the computer it runs on is going to be shut down. So all programs have a beginning, all programs have an end, and our job is going to be to fill in what's in the middle. I'm going to zoom in a little bit on these items, and we'll talk a little bit about how to use VisualLogic as we discuss generating and working with input in VisualLogic. We'll take a little break at that point then to talk about output so that we can get through all of our fundamental programming processes for this week. All right, so first things first. You'll notice this flashing arrow between beginning and end. This is where we're going to do the bulk of our work in VisualLogic. The way, or the easiest way to actually set things up in VisualLogic is to move your cursor over top of that arrow and right-click. When you right-click, you'll be presented with a number of shapes. By the end of the semester, we'll have gone through all of these shapes, we'll have used all of these, and we will have learned all of the fundamental programming concepts that will help us move forward into other languages like Python. For now, we're going to start at the top, and we are going to focus on input. So I'm going to go ahead and put an input block in here. What I want to do is have the user enter in a value and store it into a variable. So for example, I might want the user to enter their age. The way this works in VisualLogic is after you've added the input block, you're going to double click on it. Once double clicked, you will notice that a pop-up window appears. And it's going to ask you for the name of the variable that you would like to store the bit of information that you're collecting from the user in. Remember, anytime we want to store information from the user, we have to put it in a variable. And we want to use a variable name that makes sense for the specific situation that we're dealing with. In my case, I'm going to enter a name. So I'm going to name the variable name. And you'll note that if you click more, there's a couple of other options. We'll talk more about these as we go on. For now, though, you can just leave this the way it is, and we will hit OK. And now what's interesting is you'll see the name of the variable. You'll note that this is an input block. And if I go up to the top of the window and I hit this sideways play arrow, it will actually run my program. The program will start at begin, and it will execute each block in turn, starting from top to bottom. Programs execute from top to bottom in order until it reaches end. Right now, notice the program hasn't ended. We're actually paused right here. This window has popped up. We're sitting right here on this flashing block waiting for something to happen. And specifically, it's asking me to type a value for name. So I'm going to go ahead and I'm going to type in a value. One of the things that we'll talk about in a future discussion is that when we enter words for the computer, words are often referred to as the data type string. We're going to need to put double quotes around those. And I'll have a more detailed explanation of that in the next lecture, so keep an eye out for that. But for now, know that when we enter a value into a variable, we need to put double quotes around it. So I'm going to hit OK, and then my program is going to end up at the end. Notice really nothing happened. This just collected some information from me and then immediately ended. So we're going to have to think about some other ways that we can do something with that data once it's input into our system. I'm going to double click on this again, and I'm going to click more, because what I didn't really like was that it actually said, hey, enter a value for name. It'd be a lot more friendly if it said, please enter your name. And so one of the things that you'll note that you can do in VisualLogic is not only can you provide the name of a storage location in memory to hold the value that the user enters, you'll also be able to enter some words to present to the user at the time that information is entered so that you have a more user-friendly interface. So in this specific case, I'm using double quotes again around my words, around my sentence, or in this case, the string that I'm presenting to the user. And I'm going to hit OK. We always want to continue to use dialog box for now. Later on in this semester, we will cover console and file, but right now we're just going to use dialog box. And I'm going to hit OK. And let's see what this looks like the next time. I hit run, And now notice it says, please enter your name. So this is different than what we got before. There's definitely generic text that will appear. If you're happy with it, that's fine. I always like to use some type of more descriptive text so that it's a little bit more friendly to the user and we know exactly what's happening. So now that we have this information and we can use this information in some way, let's take a break and talk about output, and then we can come back and look at how we can combine these two components.